Dear children, let us continue the chapter Force and Laws of Motion. In text there are some questions in between the lesson. Now let us discuss one by one. The first question is, which of the following has more inertia? A. Rubber ball and stone of the same size. And second, a bicycle and train. Third, 5 rupee coin and 1 rupee coin. Here the question is, which of the following has more inertia? We know that inertia of an object is the measurement of its mass. What is inertia? Inertia of an object is the measurement of its mass. As the mass increases, inertia also increases. And in the question A, rubber ball and stone. A stone of same size as that of rubber ball will have greater mass. Here, even though rubber ball and stone are having same size, but the stone is having more mass, greater mass than the rubber. So, stone will have more inertia. Here, among rubber ball and stone, which one is having more inertia? Stone, as stone is having more mass. Stone is having greater mass, therefore it is having more inertia, greater inertia. Second, bicycle and train. You know that train has much greater mass than that of bicycle. Train has much greater mass than that of a bicycle. So, train will have more inertia. Train will have more inertia. Here stone will have more inertia and train will have more inertia. And 5 rupee coin and 1 rupee coin. 5 rupee coin and 1 rupee coin. Which one is having greater inertia? 5 rupees coin has more mass than a 1 rupee coin. 5 rupees coin is having more mass than the 1 rupee coin. So, 5 rupees coin will have greater inertia. 5 rupees coin will have greater inertia. Children, you write the answer. What is the question? Which of the following has more inertia? First one is a rubber ball, a stone of the same size. A stone of same size as that of rubber ball will have greater mass. So, stone will have more inertia. Mass of the stone is more than the mass of the rubber ball. So, stone will have more inertia. Second, a bicycle and a train. A train has much greater mass than that of a bicycle. So, the train will have more inertia. Next, C. A 5 rupees coin and a 1 rupee coin. A 5 rupees coin has a more mass than a 1 rupee coin. So, a 5 rupees coin will have greater inertia. As the 5 rupees coin is having greater mass, it is having greater inertia. Second question. In the following example, try to identify the number of times the velocity of the ball changes. A football player kicks a football to another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his team. See the situation here. A football player kicks a football to another player of his team who kicks the football towards the goal. Here the situation is there. First one, whenever force will be applied on the ball, then the velocity of the ball will change. Here we have to find the situation in which the force is applied. Here, first one, when first player kicks the ball towards the another player of his team, then the velocity of ball will change because first player applies some force on the ball. Here, let us consider he is a first player. He kicks the football to another player of his team. In this case, the velocity of the ball changes as he applies the force on the ball. Again, the team member, the ball which comes towards him, kicks the football towards the goal. Here, when another player kicks the ball towards the goal, then the velocity of the ball will change. Here again the force is applied on the ball. Here, the player of his team, he is another football player, kicks the football means he applies the force on the football and the velocity changes. That is the second one. Next, when a goalkeeper of the opposite team collects the ball, then the velocity of ball will change. It becomes 0. Here, the goalkeeper of the opposite team collects the football. That time also the velocity of ball changes and that becomes equals to 0. In that case also there is application of the force. Here also again the force is applied on the ball and the velocity of ball changed. Here the goalkeeper applies some force on the ball to stop. That is the third time here. Next, when the goalkeeper kicks the ball towards his own team, he catches and after he kicks it towards the player of his own team, then also the velocity of the ball changes. When the goalkeeper kicks the ball towards his own team, the velocity of the ball changes because goalkeeper applies some force on the ball. So here number of times the velocity of ball changes, that is 4 times the velocity of the ball changes. 4 times the velocity of the ball changes. Here there is a question, also identify the agent of supplying the force in each case. That is also we explained here. Children, write the answer now. Number of times the velocity of ball changes is explained below with identifying agent supplying force. First time, when first player kicks the ball towards another player of his team, then the velocity of ball will change because first player applies some force on the ball. That is when a first player kicks the ball. Second, when another player kicks the ball towards the goal, then the velocity of the ball will change. Here again the force is applied on the ball by the another player. Third time, when goalkeeper kicks the ball towards his own team, the velocity of the ball changes. It becomes 0. Here the goalkeeper applies some force on the ball to stop. Next, fourth time, when the goalkeeper kicks the ball towards his own team, the velocity of the ball changes because goalkeeper applies some force on the ball. Here 4 times the velocity of the ball changes. In each case, the force is applied by any one of the player. Now the third question, explain why some of the leaves may get detached from a tree if we vigorously shake its branch. We have to explain why some of the leaves may get detached from a tree if we vigorously shake its branch. The answer is, when a tree is vigorously shaken, the branches of the tree come in the state of motion, but the leaves tend to maintain the state of rest. Here the tree come in the state of motion, but the leaves tend to maintain their state of rest, that is according to inertia. So leaves get detached from the tree and fall down. The reason is inertia here. Now you write the answer for that question. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. Answer you write. When a tree is vigorously shaken, the branch of the tree come in the state of motion, but the leaves tend to maintain their state of rest, so leaves get detached from the tree and fall down. That is the answer you write. Now you take the fourth question. Why do you fall in the forward direction when a moving bus brakes to a stop and fall backward when it accelerates from rest? When it accelerates from rest. Here there are two situations, that is falling in the forward direction when a moving bus brakes to a stop and falling in backward direction when it accelerates from rest. The answer for this question is also in both the situation the inertia. When a moving bus brakes suddenly to stop, the lower part of the body which is in contact with the bus comes in the state of rest, but the upper parts of the body tend to maintain its state of motion, due to which we fall in the forward direction. And in the second situation, we fall backward when it accelerates from rest. When bus accelerates from rest, the lower portion of the body starts to move together with the bus, which it is in contact with the floor of the bus, but the upper portion of the body tend to remain at rest. That is because of inertia. Therefore, we fall backward. Now you write the answer for that question. Why do you fall in the forward direction when moving bus brakes to a stop and fall backward direction when it accelerates from rest? Now what the answer is, when moving bus brakes suddenly to stop, the lower part of the body which is in contact with the bus comes in the state of rest, but the upper part of the body tends to maintain its state of motion, due to which we fall in the forward direction. And when bus accelerates from rest, the lower part of the body which is in contact with the bus comes in the state of motion, but the upper part of the body tends to maintain its state of rest, due to which we fall in the backward direction. Write the reason, and the common reason is, that is inertia. In both the situation, here the reason is inertia only, but here the part of the body which is at rest, which is motion, changes. Children, we have already discussed about the Newton's first law of motion. The first law of motion says that when an unbalanced external force acts on an object, its state of rest or state of motion changes. The object which is at rest starts to move due to the unbalanced force. Also its velocity changes. That is, the object gets an acceleration. When force is applied on an object, the object gets an acceleration. We would now like to study how the acceleration of an object depends on the force applied to it and how we measure a force. You know that as the amount of force increases, the rate of change of motion also increases. So let us study how the acceleration of an object depends on the force applied to it and how we measure a force. Let us recount some observations from our everyday life. You may observe the table tennis game. During the game of table tennis, if the ball hits a player, it does not hurt him. If a ball hits a player, it does not hurt him. Why? Because you know that the force is less and the weight of the ball is also less. That is a light ball. On the other hand, when a fast moving cricket ball hits a spectator, it may hurt him. If you are watching a cricket match in the stadium, if a fast moving cricket ball hits you, you may hurt. During the game of table tennis, if the ball hits a player, it does not hurt him because of the less mass of the ball and less speed of the ball. If any loaded or unloaded truck at rest along a roadside does not cause any effect on the person standing in contact with it or in front of it, but a loaded moving truck or unloaded moving truck, even at speeds as low as 5 meters per second, may kill a person standing in its path. Here, the truck at rest will not cause any effect on the person, but so a truck at rest does not require any attention when parked along a roadside, but a moving truck, even at speeds as low as 5 meters per second, will kill a person standing in its path. That is the difference here. Here, the effect of force or the amount of force is different in each case. A bullet has a small mass and it will not cause any effect on you if you touch it or if you handle it. But a small mass bullet may kill a person when fired from a gun. Even though the bullet is having small mass, it may kill the person when it is fired from the gun. From observing all these observations suggest that the impact of force depends upon the mass of the object and the velocity of the movement of the object. Here you can conclude the impact produced by the objects depends on their mass and velocity. If an object is to be accelerated, we know that greater force is required to give a greater velocity. To gain the greater acceleration, greater force is to be applied to the moving body. Or in other words, there appears to exist some quantity of importance that combines the object and mass and velocity. Here, more the mass, more will be the force to be applied to change its position. So, if the mass is more and acceleration is more, the effect of that object is also more. So, there exists some quantity of importance that combines the object's mass and its velocity. Here there is one of the physical quantity which depends upon the force and mass. You know that mass, acceleration, velocity, force, all these are physical quantities. So there is one more important physical quantity which is depending upon the mass and velocity of the object. What is that physical quantity? That is termed as momentum. Then what is momentum? So momentum. Here momentum is one of the important physical quantity which is a product of mass and velocity. It is a product of mass and velocity. See the situation here. Here you know that a bullet which is fired from the gun is having more momentum because of its higher velocity. Similarly, the truck which is at rest is having less momentum because of its velocity, zero velocity. But when the truck is moving with certain velocity, it gains the momentum. The truck which is at rest is having zero momentum as its velocity is zero, and when it is moving with certain velocity, here it gains some momentum. As its velocity increases, its momentum also increases, and also as its mass increases, its momentum also increases. You know that the loaded truck is having more momentum than the unloaded truck. That is, as the mass increases, the momentum also increases. Now you take the example, that is a game of table tennis. Here you know that table tennis ball is very light, means its mass is less and its momentum is also less, and also that is because of the less velocity and less mass. Because of less velocity and less mass, the table tennis ball is having less momentum, so it does not cause any effect when it hits a person. Children, please note down the points what we have discussed here. What is that point? First point is, during the game of table tennis, if the ball hits a player, it does not hurt him. On the other hand, when a fast moving cricket ball hits a spectator, it may hurt him. A truck at rest does not require any attention when parked along a roadside, but a moving truck, even at speeds as low as 5 meters per second, may kill a person standing on its path. A small mass such as bullet may kill a person when fired from a gun. These observations suggest that the impact produced by the object depends on their mass and velocity. Similarly, if an object is to be accelerated, we know that a greater force is required to give a greater velocity. Now, what is momentum? The momentum p of an object is defined as the product of its mass m and velocity v. That is, p is equals to m into v. What is momentum? The momentum of an object is defined as the product of its mass and velocity. And the amount of motion possessed by an object is called the momentum of that object. Amount of motion possessed by an object. And it is also discussed that momentum is a vector quantity. Momentum has both direction and magnitude. Its direction is the same as that of velocity. And you know that the SI unit of mass is kg and SI unit of velocity is ms to the power of minus 1. Therefore, SI unit of momentum is kg ms to the power of minus 1. kg ms to the power of minus 1. Since the application of an unbalanced force brings a change in the velocity of the object, it is clear that force also produces a change of momentum. Force also produces change of momentum, because you know that to change the velocity, force is required, unbalanced force. Since the application of an unbalanced force brings the change in the velocity, application of an unbalanced force brings change in the velocity of the object. Here, to change the velocity, force is required. Therefore, you can say that force also produces change of momentum. Momentum also changes by the force. So, let us consider a situation in which car with a dead battery is to be pushed along a straight road to give its speed of 1 meter per second, which is sufficient to start its engine. If the you know that if the battery is dead, we have to push the car along a straight road to give it a speed of 1 meter per second, that is sufficient to start its engine. If one or two persons give a sudden push, means that is nothing but a unbalanced force. If one or two persons give a sudden push, it hardly starts, but continuous push over some time results in gradual acceleration of the car to this speed. Here, you know that as the force increases, the velocity also increases. Means the change of momentum of the car is not only determined by the magnitude of the force, but also by the time during which the force is exerted. Here, the momentum of the car is determined by, or the momentum of the object is determined by both the magnitude of the force and also time during which the force is applied. So it may then also be concluded that the force necessary to change the momentum of an object depends on the time rate at which the momentum is changed. Here, force is required, and also the force necessary to change the momentum of an object depends on the time rate at which the momentum is changed. Therefore, let us state the second law of motion. What is the statement of the second law of motion? The rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So, children, note down that change of momentum is determined by, first one, magnitude of force, second, time during which force is applied. So, let us state the second law of motion. So, you write statement of second law of motion. Second law of motion. What is the statement? The rate of change of momentum of an object is the rate of change of momentum of an object is proportional to the applied unbalanced force applied unbalanced force in the direction of force. In the direction of force. Then the statement of second law of motion is the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. Rate of change of moment of an object is proportional to the applied unbalanced force in the direction of force.